No, we don't even go there. All right. Concavity is concave up, concave down. So think of something holding water or letting out water. Okay? If it pours out water, it's concave down. If it holds water, it's concave up. Okay? What?
You'd think the one pointing down would be down.
No. Yeah, okay, backwards in your mind. Okay. So we have various ones concave down, various ones concave up. Where it changes from concave down to concave up is called a point of inflection. In this class, we call it poi, like what people in Hawaii eat. Poi. Yeah. Point of inflection where we change concavity. How to find the poi? How do we find critical numbers? We took the first derivative and set it equal to 0. To find the poi, we take the second derivative and set it equal to 0. Now, we can look at this drawing and find poi pretty easily without doing derivatives. Boom, right there. It changes from concave down to concave up. Here, boom, it changes. Boom, it changes, and it changes, and it changes. Okay? So that's where it goes from down to up, up to down, down to up, and so on. Okay? It's not always going to be like that, no. All right, here we go. Select the intervals where it is the first derivative is less than 0. First derivative tells me whether I'm increasing or decreasing. So when the first derivative is less than 0, I should be decreasing. Where is the graph decreasing? And where is it? Concave down. We want to see where it's decreasing and concave down. Well, I can easily say that this part doesn't matter to me. Why? Because it's increasing. Okay? So I need to be decreasing concave down. Well, this one holds water right here, right? So the rest of this doesn't matter. So it's got to pour out water, concave down, and be decreasing. Well, here it's decreasing. Here it's concave down. So basically from a half select the intervals where it's both. Well, 1 to 3 is a place where that would work. Okay, it doesn't start right there at 1. That's where it would work. What? Right there. That's 1.
Just because
it's in that zone. Okay. Okay, this one. What does this tell us? Increasing. What does this tell us? Concave down. So we got to see where it's increasing and concave down. So it's not this and not this, because those are both decreasing. Okay? Increasing, concave down. Well, it's concave down here. So this works from here to here. It's concave down from here to here. Actually, it's concave. The concavity actually changes right here because this is concave up here. It changes right there. So from -4 to -3, it works. And then from like 0 to 1, it works. And then from 4 to 4.5, it would work. So all those would work, where it's concave down and increasing. Okay. All right, G we can take a second derivative of it. So that's why they call it a twice differentiable function. Because if you can't take two derivatives of it, we can't do concavity. Okay? So which ones look like they're points of inflection? Does A look like a point of inflection where it changes from concave down to concave up? Yes, it does. Because it's bold like this. This is bold like this. Where is the split point? About where A is. Does B look like a change in concavity? Yes, concave up here. This one's concave down. It changes from concave up to concave down. Yes, B would be one as well. C, does that look like a change in concavity? Yes, it goes from concave down here to concave up here. So C is yes. D, no, that's a minimum point. It's concave down all the way through there. So no, it's A, B, and C in that point. Okay, you gotta see where it's bold down, bold up. Okay, which of those are changes of concavity for A, B, C, and D for the next one? Absolutely none of them, because it's concave up the whole time. It doesn't change concavity. It's concave up the whole time. If nothing changes, then none of them work. Any changes of concavity there? No, B is a maximum point. It's a critical number, man. C is where concavity changes. Goes from concave down to concave up. Where does it switch? At C. Okay? Changes of concavity. All right. Now, no graph given to us. Now we got to use our brains. Our brains will tell us what? Well, it'll tell us take derivatives of this, man. So let's do that. What's the first derivative of this? Negative 20x to the third plus 12x squared minus 20. What's the second derivative of this? Negative 16x squared plus 24x. 6D. What do we do with the second derivative to find the point of inflections? Set it equal to 0. Factor out what? 12x. How about a negative 12x? So we get 5x minus 2. So our points of inflection are at 0 and 2/5. Okay? Here's my number line again. 0's there. Let's put 2/5 here. Okay? That's points of inflection. Now, if we check a number in between, so if we check 1/5 in the second derivative, okay, let's put 1/5 into the second derivative. See what kind of number we get. So, somebody with a calculator, take negative 60 times 1 over 25 plus 24 times 1 over 5. What do you get? A positive or a negative number? This is going to be a positive number, right? Why? Negative 60 over 25 is negative 2.4, right? 24 over 5 is like 4.8. A negative 2.4 plus 4.8 is going to be a positive 2.4. So, it is concave up between here and here. Okay? Let's check the number 1. Negative 60 plus 24 is a negative number, right? Concave down here. If we go to negative 1, Negative 1 gives us still negative 60 minus 24 is like negative 84. It's concave down over here. Okay? So concave down, concave up, concave down. Where's the graph concave up? From 0 to 2/5. Okay? Taking two derivatives and then taking a point in between and checking it back in the second derivative. Because if it's positive in the second derivative, it's concave up. If it's negative in the second derivative, it's concave down. Oh, this one. How are we going to take a derivative of this? We can do the quotient rule really easy. X minus 2 times first derivative of the top is 0 minus a negative 5 times 1 all over x minus 2 squared. Did I screw something up? Okay. So I get 5 over x minus 2 squared. Okay. So that equals 0. 5 equals 0. Is there any? Oh. Yeah, that's the first derivative is all, isn't it? Boy, that was bad. Okay. What, Mr. Hoosier?
You cancel off the x minus 2, y is x
You have to
minus 2.
multiply first though. Because it's 0.
Okay. All right. All right. Second derivative. So if we take the bottom times the first derivative of the top, we're going to get 0 minus a negative, or times a positive 5 times the first derivative of this, which is 2 times x minus 2 times 1 all over x minus 2 to the fourth. Well, 0 minus that makes a negative, right? One of these cancels with one of these. So you got to get a negative 10 over x minus 2 to the third. So that equals 0. Are there any points of inflection? No. Are there any critical numbers? Since this matches this, basically x minus 2 matches x minus 2, you already have an asymptote there. You have an asymptote going on at x minus 2. So that's not a critical number. So what happens is, if we would graph this out, we'd have something that goes like this and like this. Okay? And I have people check the graphs on this just to make sure. But which one's concave up? Which one's concave down? The bottom one, right? Is concave down. This one's concave up. So concave down over here. So as long as it's bigger than 2. Oh, I was going negative 2. It's actually 2. I didn't do the math. Yeah. But it's 2. Okay. Okay. This one, put your thinking hats on. Okay. At negative 6, our value is negative 1. At negative 6, the first derivative is 0. So this means 0. At negative 6, it's a what? Critical number. Okay. At negative 6, it's negative 3. So it's concave down. If it's concave down, then what is my critical number going to be? A max or a min? It's going to be a max. So at negative 6 is a maximum point. Isn't that? Ooh, we're learning. We're learning what's going on. This is a test question just about every time on the AP exam because they want you to think through this type of thing. Okay. This, what does that make this point? Okay. Let's go with another one there. Okay. At 6, 7, this is 6 is a critical number. It is also a point of inflection. So a critical number where it changes. So it could be like this. Could be something like that, where it changes. It goes flat at that point. Okay. Is that a maximum or a minimum? No, we really can't tell what's going on there. We don't really know. There could be, I don't know if there would even be an asymptote there. It's tough to tell. So because the second derivative is equal to 0. Okay. So you will see problems like that today. So let me put those out. And you might have to do a little work outside of this class here. What's new, yeah.